So we've talked a lot now about getting data out of caches for reading. Let's now discuss how you write to caches. So when you write to a cache, it's a little different than reading. So for reading, we just need to move the data into the cache and then we can access it. For writing, there are two main ways to do a cache. The first is write through, and the second is write back. So a write through cache, we write the data directly back to the memory. So we're going through the cache directly to memory. And on write back, we're writing the data only into the cache. That is, we're not writing it back to memory. Write through is simple, but it's slow because we have to wait for the DRAM, whereas write back is more complicated. If the data is not already in the cache, then we need to go load it into the cache first so that we can write it into the cache, and we need to keep track of what data we've written to in the cache. Because if we write to data in the cache, then we need to remember that when we evict the line. Because if we evict data we've written to, we need to write it back to the memory. So we need to keep track of whether this data is dirty. That is, it's been written to and needs to be written back to the DRAM when it's done. So let's take a look at an example of write through. So for write through, we're always going to write to the DRAM. So the CPU is going to store value 24 to address 8. It's going to go ahead and just write it directly into the memory. Now, it also needs to look in the cache, because if we cache the data, we need to keep them consistent. So it's going to look in the cache, and if it finds the data there, it's going to update that data as well. So how slow is a write for write through? Well, a write is as slow as the DRAM. We have to write to the DRAM every time, so we have to pay that penalty. We can do the cache and the DRAM access at the same time, so we don't have to pay both the cache and the DRAM penalty. We can overlap them. So now let's look at adding allocate on write to write through. So this means that we're going to do a little bit more when we do our write. So with allocate on write, we're going to write through cache. We always write to the DRAM as we had it before. If the data is in the cache, then we write it too, but here the data wasn't in the cache. So for allocate on write, if the data isn't in the cache, we also load it. So now we're going to load the data into the cache. So why would we want to do allocate on write? Why is this better to move the data into the cache if we write to it? Well, the reason is because subsequent reads will hit in the cache. So this is temporal locality again. If we just access some data, we're very likely to access other data. So if we've written to a piece of memory, we're very likely to read memory near it. So it makes sense to load that data into the cache. Now let's take a look at write back. So in a write back policy, we're always going to write our data into the cache. So the CPU is going to look and see if the data is in the cache. If it isn't in the cache, it's going to load it, and then it's going to go and it's going to update the data in the cache. Now, there's something very important to notice here. The cache and the DRAM are not the same. The DRAM thinks the value is 16 and the cache thinks it's 24. So we need to keep track of this. We need to know if we evict this block from the cache, that we've written to it, and so we need to write it back into the DRAM when we evict it. So to do this, we're going to keep another set of bits. We're going to keep dirty bits. And these dirty bits tell us if we've written to the cache block, and if we've written to the cache block, then we know we need to write the data back to main memory when we evict it. So these dirty bits tell us if the data is dirty, that is if we've written to the cache block, and if we have, when we evict the cache block, we have to write it back into DRAM. So let's review writing to caches. So write through is a simple but slow approach, and write back is more complex but faster. So for write through, we have to wait for the DRAM every time. Write back is much faster because we just write to the cache and don't have to wait for the DRAM, but we have to keep track of dirty data so that when we evict a line, we know if we need to write it back to DRAM. So we saw allocate on write as well, which loads the data into the cache when we do a write. And this is a benefit because of this temporal locality. If we've just written to data, we're very likely that we're going to use the data near it in the near future. So today, almost everything is write back because of performance. There's actually one major exception, and that's Intel's new Xeon Phi. This has an L2 write-through cache, and they did this for simplicity. It has 56 cores, and they wanted to optimize the simplicity of those cores, so write-through is simpler for them. But it's a performance problem, and this is one of the reasons they have a hard time getting performance.